So megafloods are per definition very rare events, and that means that we don't know much about how they get triggered and how often they occur. And that's why we spend a lot of our time collecting historical data of such events. And this means basically that we search all over Europe of past megafloods. And then we use this enriched database to have a more robust understanding of the statistics of this kind of events. Over the past 25 years, we've built a rather unique monitoring network, including meteorological stations and river monitoring sites. And this uniqueness relates to the fact that although Luxembourg is a small country, it has a very diverse geology and has different land use types, and all this while the climate is rather homogeneous. And this actually has the country standing as a natural test bed where we can study how different configurations of physiographical settings translate into hydrological responses. So for looking into the future, we actually rely on mathematical models, which are simplifications of the reality. And most of these models actually rely on the assumption of stationarity, so meaning that we live in a world that doesn't change. And of course, we know that this isn't true. And so we push those models increasingly beyond their design limits as soon as we project ourselves into the future. So we face the difficulty that we only have 100 to 150 years of meteorological and hydrological observations. So we know actually very little about the past functioning of our rivers. And we need to tap into other sources of information like natural archives. It can be tree rings, it can be living organisms in rivers such as freshwater mussels that act as recorders of past environmental conditions. And we use those recordings for reconstructing the past, and the knowledge that we gain from these archives will then be leveraged for improving our predictions of the future.